everyone, welcome to the second video in the Geometry Crash Course series, and I thought we'd just start this first video by finding the surface area of major figures in geometry. So if we start with our cylinder with radius r and height h, the surface area is given by 2 pi r times the quantity r plus h. That's done by finding the area of the two bases times the area of the part that wraps around the two bases. The sphere surface area is given by, if this is the radius, 4 pi r squared simply. If this is the cone, this is the radius, this is the height, and the surface area is given by pi times r plus L. Well, L is the slant height, this height right here, that runs down the cone, and we can find that because if we know this is the triangle, where this is L, this is R, and this is H, it's a right triangle because it's a right cone. We can use Pythagorean theorem on that. Then we have our box length times width times height, and the surface area is simply given by 2 times the length times the width plus the width times the height plus the height times the length. And that's simply just done by, we're taking each face, so this is width times height, and there's two of them, and then length times width, and just all combinations of them. And the pyramid is the one that's most up in the air, because the base could be anything, but basically we'll just call it base area, that's how to denote that, plus the area of the faces. And you just adapt that to how it is. So the area of the faces are triangles, and they're going to be all the same if this thing down here is a regular polygon, and the base area is just going to be a regular polygon. So this one has no concrete formula because there's no such thing as a pyramid that's just generally accepted as a pyramid, but it's not that difficult to find. Okay, given that, we're going to move on to angles. So angles are a very important thing in geometry, and basically here's a couple things that are very important to know about angles. We'll start with our triangle, and then we'll have a square, then we'll have a circle. Triangle has 3 angles, so 1, 2, 3. And I didn't have to draw that. It looks equilateral, but it could have been any such triangle whatsoever. And what's always true is that the sum, that's a sigma, of the angles in a triangle equals 180 degrees. There's always 180 degrees in a triangle no matter what. And for a quadrilateral, this is a square, but I could have drawn any quadrilateral. It could have been a rectangle, could have been something very irregular. But no matter how it looks, the sum of the angles is always equal to 360 degrees. And for a circle, the same thing applies. The sum of the angles inside a circle, and it's weird to think about because there's not really any angles in a circle, but the sum of the degrees in a circle, whereas if this is our center point and we measure from here all the way around, that's going to be equal to 360 degrees as well. And we're going to actually generalize this to any n-gon. So let's say we choose a pentagon. So let's look at the pattern here. From 180 to 360, we increase by how much? We increase by plus 180 degrees. And if we increase 360 by 180, we get a 540. And that, it turns out, is the sum of the angles in a 5-sided polygon, such as a pentagon or any irregular one. And if we want to find a hexagon, we simply increase that by 180 again, and so on. So that you get a general theorem, which says that if you have any n-gon, you're going to take n minus 2 times 180. So that's going to be a multiplication, and that's going to give you the number of degrees in there. So let's just test out with the triangle. Put 3 as n, that becomes 1 times 180. We put 4 for the square or quadrilateral, we get 2 times 180, and so on, 3 times 180, and it always works. So that's basically angles. And the last thing this video will cover we'll be covering some paper. Okay, we're going to be covering triangle centers. So we're going to draw some triangle right now. It's not going to be a regular triangle or anything. So here's our large triangle. Here's our triangle. And we're going to be drawing the triangle centers. So first of all, the first type of center of a triangle is called the centroid. And that's done by taking the midpoint of each side. So I'm going to approximate, and let's say that's the midpoint, that's the midpoint, that's the midpoint. And we draw the line that's coming from the opposite angle to the midpoint, simply like this, and final ones like this. And you can see that it didn't approximate it very well, but here would be the centroid of the triangle, and they'll always meet in one point. And this is actually called the balancing point, which means if we were to take, say, a pencil or something and put it on that point and hold this figure up, it would perfectly balance if we cut the triangle up. So this is called the centroid. The centroid is found by taking the medians of each side. So that's the line that goes from the middle of this side to this angle. So that's the centroid. Then we're going to be finding the incenter. That's done by finding the bisectors of each angle. So this angle, bisector of the angle, is basically done by taking half of this angle. So I have to have a protractor, and this angle turns out to be about 80 degrees, so I'm going to mark it at about, it's 100 degrees rather, so it's going to be about 50 degrees. So right here, I'll just draw that one. Our angle here happens to be what? This is about 45, so I'm going to mark it about 22-ish. So this last angle happens to be about 35, so I'm going to mark it about like 17-ish. So around there. Remember, these are the bisectors of each angle, and they all meet one point again. Should meet in one point. These are approximations, of course, and that's called the incenter. So I'm going to color code this. The incenter is the point where they meet, and that's the angle bisectors. And the next one we're going to do is the circumcenter, which are the perpendicular bisectors of each side. So basically we're going to find the middle of each side, which we already know from the green markings. And so this is the middle of that side, this is the middle of that side, and this is the middle of that side. And what we're going to do is we're going to draw a perpendicular line just downward. Let's use brown. Like this. Perpendicular line. Let's try to use this to find the perpendicular. So here's 90 degrees. Let's see if we can actually get a good point here. And from here, this is perpendicular. And here, the brown center you see right here, that is called the incenter. So, sorry, that's not the incenter. This is the circumcenter. Circumcenter is done by finding the perpendicular bisectors. And the interesting thing about this center is that any 3 points define a circle, which means that the 3 points that define this triangle, so these 3 points, 1, 2, 3, define a circle. So we can draw some kind of, I'm going to draw in pencil, some kind of circle. Big circle probably continues down here. But the point is that this brown dot we found, that is the center of that circle, so that's interesting to know. And we have one last center to talk about in this video, and that's going to be the orthocenter. And that's going to be taken by doing the altitudes. So what is an altitude? It's basically, you have to start at this point, and you have to go perpendicular down. So one there, start at this point, go perpendicular. Let me actually do an angle. Perpendicular to this side, of course. So this is where it gets weird. Okay, I'll just go down. And as you can see in this one, it's not even gonna be on the triangle. It doesn't have to be, because you can pretend that this side continues like this. It's weird to think about. And then this last one, our perpendicular here, we'll just line it up. That is not going to be on here either. So actually, what's interesting about this one is because I drew an obtuse triangle. With any obtuse triangle, all the altitudes won't end up inside the triangle; they end up outside. So if we continue this, we'll just imaginary take a different paper here and just continue these lines. And we'll get something like this. And they should meet in a point. So those are triangle centers, so until next time.